Alright, greetings ACT specialists. So we took a look at a combustion reaction and now we're taking a look at a single replacement reaction. And reminder, we know this is single replacement because we have a single element like aluminum, and aluminum is feeling all alone, single, gets really jealous, sees silver hang out with NO3, and it's like, man, this happy couple has got to change. So aluminum, being real sneaky, kicks out silver from this relationship, and after the reaction you see silver is left all alone, and now aluminum is happy in its relationship with NO3. Okay, pretty crazy stuff happening here with the elements. So single replacement, we know that, and we actually took a look at a similar reaction in the lab we did. In the lab, reminder, we still used AgNO3. We used exactly the same thing, AgNO3, but with that time we mixed it with copper, and that's how we got the silver to form. So we've got this similar reaction, and in this case we're using a little bit more, we're using a little bit more of the AgNO3. Okay, we're using 1.50 grams. In the lab I believe we use 1. So we should get more silver as well. If you remember in the lab, I think we got like 0.655 grams we were supposed to get. So we should expect maybe a little bit more silver from this reaction. We'll see. Okay, and remember in the lab we used a sheet of copper, but here I'm going to use a sheet of aluminum to try to get that silver out. Now aluminum, it's going to be harder to see the silver. They're both shiny metals, but hey, through the reaction we should see a change. So I need to know how much aluminum to use. And I'm just going to say that this is solid. Remember, this was aqueous. I think aqueous meant that it was dissolved in water. AlNO33, I believe, is also aqueous that will form, and we're hoping to form solid silver. Okay, so I know I've got 1.50 grams of AgNO3, and what I want to know is, well, how many grams of this aluminum do I need to add? Because I don't want to add too much. I don't want to waste my aluminum. I just want to add enough to react with all 1.50 grams of this. So I'm thinking, okay, well, I need to convert to grams of aluminum. So I'm starting here, and I want to get to my grams of aluminum. Now, I would like to go from grams to grams, but I don't know how many grams of aluminum I need to mix with grams of AgNO3. That doesn't really click in my brain. That doesn't make sense to me. But I should be able to figure out how many moles of aluminum I need to mix with moles of AgNO3. And I can do that by looking at my equation here. Now my equation here currently is not balanced because, look, I've got NO3, but I've got 3 NO3s here. So I've got 3 of this NO3, but I've only got 1 NO3 here. So to fix that, I'm going to put a 3 in front of here. That gets me 3 NO3s, so that's done. But that also gives me 3 AGs. And I only got 1 AG on this side, so I've got to put a 3 there. And once I put a 3 there, I think I'm balanced. Yeah. Okay, right. Same amount of ALs. Nice. So I know from my reaction that for every 1 mole of AL, I need to react it with 3 moles of AG. So if I were to add 2 moles of AL, I would need 6 moles of Ag. Or I could think of it the reverse. If I have 9 moles of Ag, well then I need 3 moles of Al. I need 1/3 of that. And so my first step is, well, that would be nice if I knew the moles of AgNO3, because then I could just, use these numbers. So my step 1 is going to go to moles of AgNO3. As I said, once I know the moles, I can figure out the moles of Al. Okay, and once I know the moles of Al, I can figure out the grams of Al. So that's my plan. And so I'm going to start with my first plan. I'm going to take this step by step. Grams, and at the end I'm going to show you a quicker way if you feel really confident with this. But for now, let's take it slow and steady. Grams of AgNO3 to moles of AgNO3. Okay. Alright, well, I know I've got 1.50 grams of AgNO3. And I want to cancel that out. Well, let's see. I want to cancel out my grams of AgNO3. I'm going to my moles of AgNO3. Alright, and now I need to know the relationship between moles and grams. Oh wait, how do I get that? Right, the periodic table. So the periodic table tells me how many grams are in 1 mole of AgNO3. Well, Ag is 107, I think. I could be wrong. So if so, this calculation is going to be wrong, but you can fix that. Plus 14 plus 3 times 16. So that's 169.87 grams. So 1.5 divided by 169.87. So that's going to give me 0.00883 moles of AgNO3. So I'm going to put this right here, 0.0883 moles of AgNO3. I'm like, well, I know I've got 0.0883 moles of AgNO3. How many moles of Al should that mix with? Well, I know for every 3 moles, I need 1 mole of Al. So for every 3 moles of AgNO3, it mixes with just 1 Al. So I know this number is going to be less because I only need 1 for every 3 of these. And I could, maybe you have an intuition of how to do that, but I'm just going to do the calculation and then reason it out. Moles of AgNO3 to moles of Al. Let's switch a color. Let's go to blue. Okay. All right. So that's this step. And I'm thinking, great, 0.00883 moles of AgNO3. I know I want to cancel out my moles of AgNO3 to get to my moles of Al. And I know, well, according to this, for every 1 mole of Al, I need 3 moles of AgNO3. So let's start with this. 3 moles of AgNO3 per 1 mole of Al. And so it's telling me to divide by 3, basically. 0.00883 divided by times 1 divided by 3. That's how I'd use my fractions. 0.00294 moles of Al. 0.00294 moles of Al. Okay, I'm there. And now that I know my moles of Al, I can convert back to the grams, and we've done a lot of examples with that, so I'm pretty confident you can do this to go from moles of Al to grams of Al. Well, I've got 0.00294 moles of Al times, I'm going to cancel my moles of Al to get to my grams of Al, and 1 mole, if I look on my periodic table, I know there are 26.98 grams of Al per 1 mole. 0.00294 times 26.98 gives me 0.08 grams. So I only need 0.08 grams of aluminum. That's not much. That's probably like, I don't know, that much. So I don't need that much aluminum, which is good. I can use the aluminum to wrap my sandwiches or whatever. Great. Nice. Okay. Cool. Cool. I think. Why do I feel like I did something wrong? Let's think. 1.5 divided by 8. Oh, okay. I think that's okay. I think that's reasonable. All right. Cool. So I've just figured that out. All right. It's a small number. I don't need much aluminum. Great. Let's take a look at what we need to do next. Oh, okay. Now I want to know how many grams of pure silver can I produce. So now let's think about what I know. I know how many grams of aluminum I have. I know how many grams of AgNO3 I have. And now I want to know how many grams of pure silver I can make. That doesn't work. Okay. Sure. Let's use not yellow, red. Pure silver. Pure silver. All right, try again. Pure silver. Pure silver. Okay, so I want to know how many grams of silver, Ag, can I produce, which is over here. Okay, so I could start with what I started with, 1.50, but I've already converted that to moles, right? So I might as well use the moles that I have here to convert to my moles of Ag. And remember, whenever I'm going from moles to moles, so this is important to remember, is I want to look at the relationship in my chemical equation. I want to look at my coefficient. So you see how this is 3 and this is 3? Meaning if I have 3 moles of AgNO3, I'm going to make 3 moles of Ag. So if I have 6 moles of AgNO3, I should make 6 moles of Ag. And if I have 0.0883 moles of AgNO3, well, I should also be making 0.0883 moles of Ag because they're the same. But just in case you're not convinced, let's do that mathematically. I'm going to call this step 1. In step 1, I'm going to go from my moles of AgNO3 to my moles of Ag. And I'm saying, look, I've got 0.00883 moles of AgNO3. That's what I know. And I know I'm trying to get to my moles of Ag in this first step. So I know I want to cancel my moles of AgNO3. I know I want to get to my moles of Ag. And I'm thinking, well, what's the relationship between those two? Oh, my chemical equation tells me for every 3 moles of Ag I want to make, I need to put in 3 moles of AgNO3. 3 divided by 3 is just 1, so this is going to give me the same thing. So yes, our reasoning worked out, and I've got 0.0883 moles of AgNO3. Nice. All right, so let's go back here. Let's say I want to now go to how many grams I want to make. So let's start with that, 0.0883 grams. Nope. Let me redo this. Let me just write out my plan. My plan is to go from my moles of Ag to my grams of Ag. Well, I know I've got 0.00883 moles of Ag. I'm trying to cancel out my moles of Ag to get to my grams of Ag, and I see, okay, well, in 1 mole of Ag, I have 107.87 grams. I'm not sure that's the exact number. Yeah, let's just say that's good. If not, please correct me, 0.0883. I'm trying to do this off the top of my head. Can't really remember at this point. I think that gives me 0.95. 3 sig figs grams of, oh, I should have kept 3 sig figs here. Okay, well, I should go back and fix that. But for this one, I know I've got 0.952 grams of Ag. Okay, so let's think about, let's just pause there for a second and think about what I figured out. I figured out that if I mix 1.50 grams of AgNO3 with 0.08 grams of Al, I should make 0.952 grams of silver. Okay, and so hopefully that's the amount I get in my product. All right, but let's think about this a little bit more and think about whether our answers are reasonable. And so one way is to look at your moles and say, well, I need I need 1 mole of Al mixing with 3 moles of Ag. So if I have 0.00294, I should need 3 times as many Ag. That's about 3 times that. And remember, just to check, the 3, so that means this number should be exactly the same as that number, and there are. So my moles check out, and my moles look reasonable. Now, if I want to be sure, I can always add up the grams of my reactants and compare it to my grams of my product. But right now, I'm still missing one of my products. So I'm going to do that calculation quickly and show you kind of a neat way you can do things. You can kind of narrow down your steps. So I already know my moles here, so I know I'm going to need to convert here and then down here, right? So I need to go from moles to moles, then moles to grams. So moles of AgNO3 to moles of AlNO3 to grams of AlNO3. That's my plan. So I can do this all in one step if I go from moles of AgNO3. I could really start with moles of anything, but let's just do AgNO3 because that's where I've been working mostly out of, what I've been starting with, to moles of AlNO3, and then to grams of AlNO3. So my moles of AgNO3, well, I'm starting with 0.0883. Did I make a mistake in the last one? Oh, it looks okay. All right, so 0.0883 moles of AgNO3. Okay, and well, how do I get to my moles of AlNO3? Well, I need to cancel my moles of AgNO3. My first step's to go here, so moles of AlNO3. I don't like this green, hard to see. And well, what's my relationship between moles of AgNO3 and AlNO3? Well, for every 3 moles of AgNO3 I use, I only make 1 mole of AlNO3. That's what my equation tells me. So these cancel out. I have moles of AlNO3. So I'm not done yet because I finished this step. I'm here. Now I've got one more step, and that's to convert from moles of AlNO3 to grams of AlNO3. And so I know from my periodic table, it tells me how many grams are in 1 mole. So Al is 26.98 plus, now there's a couple ways I can do this. I'm going to take 14, the N, plus 3 times 16. I'm going to multiply all of that by 3 because I have 3 of those NO3s, and I'm going to add them to what I have. And that's going to give me 212.98 grams of AlNO3. Yeah. Okay, so I take my calculator, I take 0.0883 moles, I times the 1 divided by the 3, and then times the 212.98 divided by 1, and that gives me something wrong. Oh, no, I calculated this number wrong. Sorry. I think, let's see, N14 plus 3 times 16 times 3. No, maybe not. 26.97. That's 212.97. Huh. 0.00883 times 107.97. I see. So I did write this number wrong. This should have been 0.00883, and this is 0.0083. So I did use that for this calculation. And so I should have started with this number, 0.00883 divided by 3 times 212.97. And that's going to give me 0.627. Okay, sorry about that. So you might want to go back and realize that for this number, it should have been 0.00883. And so when I convert over here, that should have also been 0.0083. And I use that for this calculation for some reason. So this number is right, this number should be right, and these should be right. So to check this, what I should figure out is that, I should find is that everything over here on the left-hand side, the reactants, should equal everything on the right-hand side. So let's see if that's true. Well, on the left-hand side, 0.08 plus 1.50. Does that equal 0.627 plus 0.952? And well, the left-hand side is 1.58. And does that equal 0.627 plus 0.952? Gives me about 1.579. And yeah, those are really close. So I know that I've done this problem correctly because my reactants add up to my product. So I do apologize for the mistake here. This should have been 0.00883. I'll have to look back at the video, but I think that's what I calculated. I just wrote the wrong number here, and as a result, wrote the wrong number here. These numbers ended up okay. So, all right. Well, I know that was a little confusing, but hopefully it was still helpful when you're doing these missions where we're taking back Saturn. These are good ways to check whether you have your answer correct or not. All right, till next time, King out.